Hi everyone, I hope you can hear me clearly. Just let me know if the sound is okay or not. It should be fine, but if anything goes wrong, just let me know. So we have some AIs entering the chat. So welcome everyone. Thank you for your presence. The goal today is to talk about a few topics that have been discussed in the solar industry for a while now, but let's say that the numbers are still not quite in people's mind. I believe that the more people are aware of the impact of soiling on PV plants, the more will be done to make the plants achieve their performance. The idea today is to go through what we have learned in the past 6 years at Chemitek around performance, around payback, return on investment, what we have as solutions to mitigate soiling, and especially the impact that the soiling can have on the numbers of a PV asset. So soiling accumulation is not just an aesthetic issue, as most of you will agree. It is a systematic problem and that drags down the performance of a plant. It can be very little as 1 or 2%. It can be as high as 80%. It depends on situations. Of course, 80% is not the common number, but 2% is also not as common as the spreadsheets might make it look like. For now, we see a lot of companies that still look at soiling as a cell in the spreadsheet, where they just set a number, an expectation on the soiling for that asset, and it's unattended during the lifetime of the plant. Some already have soil measurement devices, still quite uncommon, maybe because the companies don't see the benefit, or maybe because it's just too expensive. The common solutions found in the market are quite capex intensive, especially if you want several reading points. But nowadays, with the advent of drone inspection and with drones now being able to contribute to the soiling measurement, we believe that soiling will be much more spoken about now that data is more systematically available. So what's the particular side of soiling is that it's a slow-acting thief. It doesn't appear as an alarm on most SCADA because it's a slow degradation. And by being a slow degradation, the problem stays under the radar in a lot of companies, in the majority of the market. Another thing that we believe that it's important is to use the actual cleaning to apply protection to the panels, so that you are protected not just or you are producing more not just immediately after the cleaning, but still you can make your asset produce more between cleanings. Nowadays, most asset managers look at the main metric, which is performance ratio. But the issue with performance ratio is that it measures all the problems on the plants, not just soil. So if you have soiling, if you have degradation of the panels, if you have hotspots, if you have string asymmetries, all of that will contribute to a lower performance ratio. Of those, it is recognized in the industry that persistent soiling is the one that has the highest impact besides irradiation. Irradiation is the number one parameter that can change the production of a site. The second one is the impact of soil. The problem with these slow losses is that there aren't really responsibles for that for those losses. Soiling is nobody's responsibility. It just happens. Panel degradation is also an intrinsical thing to the panels themselves. So they will not. There isn't any brand that does not degrade. So it will always happen. Hotspots are most of the times only detected with inspections, and string asymmetries should be accounted for by the design and also before delivering the asset to the asset manager. So in the end, those are problems that are not assigned to anyone particularly. And what happens, especially in the case of soiling most of the times, is that when a soiling problem is detected, it goes into the budget of the O&M. So the O&M manager will need to make it fit in their budget, which in reality should not be just responsibility of the O&M management, especially if it's not the typical soiling or it's above the predicted soiling for the plant. If you predicted 2% and the plant is now losing 10, your budget should be adjusted for that. But 99% of the time it is not. So what happens is the O&M management will have to handle the extra cost of the extra cleaning or of the specialized cleaning, while the asset management will be the one having the impact of the added revenue. So, and that's why I'm sure a lot of you feel that as O&M managers or even cleaning companies, there isn't really motivation for to clean to solve the problem, especially if the budget is already short. So that is why we end up doing the bridge in several companies, doing the O&M and the asset management, because the asset manager is the one that needs to act in order to protect the performance ratio. But most of the times it will look at cleaning and soiling as something that needs to be addressed once per year, not really something to be controlled or prevented. So what happens is that soiling is only addressed when it's just too loud to ignore, when the losses are so material, so big that you just cannot ignore it anymore. And by that time, you are losing much more than predicted. The cost of solving the issue will be much higher than predicted. I brought a few numbers so you can check the impact that contamination and dust can have. Starting with cement dust, it's something that we find a lot worldwide. Cement factories are heavy energy consumers. They are, most of them, committed to going greener in the next few decades. So it's only natural that they invest in solar. The problem is that the environment around cement plants can be quite dusty. So they end up having important losses. And to give an idea, 40% of performance loss on a cement plant is not that high. We have found a lot more. But on a 10 megawatt plant, 40% can mean that you will have over 700,000 euros of annual losses to soil. That is enough to completely destroy the payback of that plant. What was before expected to be paid in 7-8 years, now it can take you 15 years to be paid. So especially if it's a PPA, a power purchase agreement, it's even more critical, because then the rate of return will be near zero if you have sustained losses of 40%. When you need to address the issue with a specialized cleaning, for example, we are talking about maybe having to spend 100,000 euros to fully clean the plant. It seems a lot, especially when compared with a normal water cleaning for dust. But the reality is spending those 100,000 euros will be a smart decision, and it will be very easy to recover. We are talking about a payback of less than 2 months for that. And every day that the decision is not taken, it will cost 1,700 euros. So it has happened to us a lot, where the time to decide on the cleaning ended up being more expensive than the cleaning itself. The decision took so long to be made that by that time you already had spent more or lost more on the production than what it would cost to clean the plant. If we look at something more common, which is dust, where achieving 10% of losses in soiling on a 100 megawatt plant can represent around 1 million euros. 10% soiling is a significant soiling for dust. If we come to south of Spain, the Maghreb region, that are dusty areas and with sandstorms and all that, achieving 10% can be quite fast. So it's something that needs to be managed closely, because otherwise the impact on the financial of the asset will be quite big. To give you an idea, using a soil mitigation coating to reduce the buildup of dust on an asset in those areas, on the arid and semi-arid regions, it can bring you around 30% of your losses. So if you, in this case, you are losing 10%, applying a coating should be able to give you around 3% of recovery. Those 3% of recovery will represent 270,000 euros. Coating it a little bit above 12,000. So in the end, the payback 3 weeks, more or less, an ROI of almost 1,000%, and you get 250,000 euros of added revenue each year. Also, you will be mitigating the appearance of hotspots, for example, by keeping your panels clean. Once again, not mitigating soiling will cost around 700 euros per day. Just the simple fact also of having a coating in your plant can mean that the payback of the plant can be faster from half a year to a year, in this particular case, of course. So it makes sense to apply a coating, even though it's not yet the standard of the industry, but we see it as becoming the standard of the industry. So we are working now in with several companies to start to introduce the topic of soil mitigation in a more structured way. We have been working with several. We can see here some results of the tests and of the customers that we already have, a little bit around the world, from Honduras to India to Malaysia, Israel. Those are some of the results we have, and especially also on different scales. We wanted to test it on different scales and making sure that it would work on all of them. So from utility scale of 60 megawatts to a residential plant of 8 kilowatt, it makes sense. That's reality, and with a very low cost for the owners. So for that, and to help with the math, we developed a web page that you can find at performance.chemitek.solar that allows you to play a little bit with the numbers. You have there a lot of the information that's it's in this presentation today, and you have a calculator there where you can input your own numbers and see the type of gains that you would get from soil mitigation coating. Of course, you need to have in mind irradiation, you need to have in mind PR losses, the type of contaminant that you have. So all that is foreseen, and I think it can be interesting for any person that is looking into know more about the metrics around PV managing. There's a lot that you can take from there, and also if you are into cleaning, you have some valid points to present to your customers to validate the cleaning. Also, when facing problems, that's when cleaning makes even more sense. So give it a try. We'll continue to develop it in the next upcoming months, adding functionalities to it, but you can already get numbers, get some metrics that you can add to your offers, that you can present to your management of the returns that you can have by applying a soil mitigation strategy. So regarding what the technology that we have for soil mitigation or anti-soiling coatings, we have two main technologies. One is the anti-static coating, designed for dust, for dry areas like arid and semi-arid climates, being deserts, being areas where most of the year you have the panels remain dry, and it doesn't need the water to perform. That's the big advantage. That's why also is the technology that we recommend to most customers, because you don't need to wait for the rain for the coating to be of service. No, it acts based on anti-static principles. It dissipates the static electricity from the surface so that the fine dust is not attracted to the surface, and therefore you are able to keep the panels cleaner. Also, it provides anti-adherent properties, therefore it becomes much simpler to clean afterwards. Also, if it rains, a bigger quantity of dust can be removed, which is a benefit also to have in mind. Of course, in dusty areas, probably just rain alone will not be enough to keep your panels clean. Also have in mind that on the lower side of the frame, you can create some hotspots due to the buildup of dust once it dries. So it will help you clean and clean faster, so to speak. The other coating available, the other technology available for coatings is the hydrophobic coatings, probably the ones, the technology most known worldwide, can be used in cars, even in clothes, camping tents. Hydrophobic coatings have several decades in the market already. But we find that for solar panels, it has a limited application. So it's a good solution for wet environments. If it rains a lot, if you have a lot of humidity in your area, if it's a tropical area where there is a lot of condensation on the panels during the night, for example, the hydrophobic coating is probably the best solution for your case. If you are in the UK, it rains a lot, or Germany, those are the cases where having an hydrophobic coating will help you. Also, it works with snow. It will help you remove snow faster and easier if you want to brush it off. So in that sense, it has limited application, but the reality is, when compared on the rainy days, on the wet days, compared with the anti-static coating, it will outperform largely the anti-static coating. You just need now to consider, are my panels wet most of the time or not, to be able to choose which coating to use. So with those two technologies, we developed 4 products. We have the anti-static coatings with the Solar Wash Protect and the anti-static solar armor. The Solar Wash Protect is the main product, the best seller of one of the best sellers of Chemitek, and it's a 2-in-1. It's something that you can use on a regular base to clean your panels. It's a pH neutral cleaner, and integrated in the formula is our anti-static coating. The benefits of that is that when cleaning, you are actually applying also the coating at the same time, brushing the coating into the panel, and once it dries, you have your panels protected. The Solar Protect is more directed to manual cleaning or robotic cleanings where the level of contamination is high, like bird droppings. And we have the anti-static solar armor, the 2.0. It's the version that we launched last year at Intersolar, that now lasts for a full year as a minimum. It was designed to be used with machines like the Sunbrush, with brushes on tractor, where you just mix it in the water and you apply it during normal cleaning. The difference between the Solar Wash Protect and the anti-static solar armor is that the anti-static solar armor does not have any type of cleaner. It's just the coating, because when cleaning utility scale with a sun brush, you need to be sure that you clean in one pass. There is no way of accommodating the extra cost of rinsing the foam created by a product. So we did this version also with a dilution thought for the sun brush that usually has an IBC of 1,000 liters in the bag. So you just add 1 kilogram of anti-static solar armor